Today we will be learning how to balance chemical equations. We have here two unbalanced chemical equations. And what does that mean? It means that the element numbers in the left side, which is the reactants, is not equivalent to the number in the products. So we need to make sure that everything is the same from the left side and on the right side. We have here coefficients and subscripts. It's important to understand this first before learning how to balance chemical equations. Coefficient is going to be that number we have before an element. It represents a number of molecules, while subscripts, it's that little bottom number over here. It represents the number of atoms in a single molecule. Your subscripts can never change. So when you're balancing chemical equations, you're only going to be changing the coefficients, but never, ever the subscripts. So it's important that before starting everything, it's always good to write down the number of elements that you can count. It makes it so much easier. So we have here sodium. How many sodiums there are? There are only one of them here, and then there are two chlorides. Now on the right side, there's one here, and then there's only one chloride. Now that's where the imbalance comes from. It's because of these numbers right there. So what we're gonna do, remember also that coefficients are always gonna be the numbers that have to do with multiplication, which is why I wrote here x and then plus for subscripts. When we have a number that's in front of an element, we always multiply it to the next, doing a distributive property. So we have here Cl, and we want to make sure that it's equivalent to that one on the left side. Always start with the smallest. So chloride 1, we're going to multiply it to 2. Now we have 2. Perfect, right? That's good, balanced. However, remember I said a while ago with distributive property, there's one of Na, and if we multiply it to 2, now we have 2 sodiums. So now this says 2. Now the sodiums are no longer in equilibrium. They're no longer balanced with each other. So we're going to have to change the one on the left. So what we're going to do over here is we're going to multiply Na with 2 as well. And we do that, now we have a balanced equation. Because I multiplied it with 2, I made sure that that's going to be the coefficient. Now we have a balanced equation. There's the same number of reactants with the same number of products. And then moving on to the second chemical equation. So we're going to list the same thing. On the left side, we have 2 hydrogens. On the left side, we have 2 of the oxygens. Now, when we look on the right side, there's 2 hydrogens, which is perfect. However, there's only 1 oxygen here. So what are we going to do? We're going to once again do what we did a while ago, times 2, times 2. Perfect, perfect. However, now there's 4. So what we're going to do is times 2. Now, 2. It's 4 because 2 over here times 2 is 4. And now we have a balanced chemical equation.